to give like some visual of it, and then we'll just do the problems without wrapping them, but you might as well get one kind of explained.
Mm-hmm.
And let me snip this in here. Actually, let me change this to, yeah, that's a little better. Snip in nicer. Okay, so here is the graph. And where I'm struggling a little bit is they're using language like it says lower sum, upper sum, upper sum. The correct language is left sum and right sum. So I will be taking a moment here to look this one up on the internet to try to figure out what they actually mean, so I can give you the right answer. We'll work through this. All right. Sorry. Sometimes I mean, I could just we just do it and then it might be wrong. So it's worth me spending a minute here to figure out what it actually wants.
Yeah, I understand.
You just have to sign in. Okay, sign in. Oh my goodness. It wants me to give him a code. I haven't logged in probably in a week. There it is. Oh, wait, something. All right. Okay, I still don't have a good answer for this, but the lower sum using two rectangles, it's not even a rectangle. It's the height here, which is a
Uh-huh.
height of 0, and then it's a height over here of also of 0. And so it's a terrible picture for the first one. The first one is 0 plus 0, which is 0.
Okay.
Now, 4 rectangles is going to be a little more interesting here. So for 4 rectangles, imagine you're cutting up this minus 4 to 4 into four pieces. You would cut it at -2, 0 and 2 like that. And so this next rectangle has this height here, and same with this one over there like that.
Okay.
All right. So to get the height of the rectangle, you have to evaluate the function at -2. Right, you have to figure out what is f of -2, which means 16 minus -2 squared, which is 12. So this is a height of 12, a width of 2, a height of 12, height of 12, width of 2. So your area of each rectangle is 12 times 2 plus 12 times 2. So 48.
Okay. Okay. Yeah.
Now they're lowers. The reason they're lowers, so that's 48. The reason they're lowers is because they're inside. See how the rectangles are contained inside the
Mhm.
curve here?
Yes.
The uppers are going to be outside. So we're now going to do the uppers. I'm going to grab this. So the upper, it would be up here. It would be like this. This is one of the rectangles,
Mm-hmm.
and then the other one goes the other direction.
All right.
So width of 4, height of 16, width of 4,
Mhm.
height of 16. That's for two rectangles.
So it'd be 16 times 4.
Yep, 64 plus 64, which is 128.
Okay.
Now that's for two rectangles. 128. Now for 4 rectangles, I'm gonna grab this picture one more time. So there's this one. And again, they're all kind of above or outside. So this is 2 and 12, 2 and 12, 2 and 16, 2 and 16.
So would it be 12 times 2 plus 16? Well, it would be 24 plus 24 squared plus 32 squared.
So yeah, so you got 32,
Mhm.
24, 32, and 24.
Okay.
So I think that's like 112.
Yeah, sorry, I'm checking right now. It's pulling out my calculator. It's 112, yeah.
Great. So yeah, hopefully that's the only one of those that we have to do because it's not correct the way we're doing it. Right, yeah, so this is number 2 is kind of more of the question. Let me see if there's a left sum or right sum. Let's do number. Oh boy, just these are all unclear. Let's do number 3.
Okay,
We'll come back to 3 is more like 1.
okay.
Okay. And the kind of the way to do this problem here, let me snip it in, is to actually just find both sums, what are called both the upper and the lower, and not know which one is the upper and which one is the lower. So here's what I mean by that. We're going to do a sum using these points here, 0,
Mhm.
1, 2, and then we're going to similarly do a sum for 1, 2, 3, and 4. One will be bigger than the other. That'll be the upper. One will be smaller than the other, and that will be the upper. Okay, so here's how this works. The area, which is what we're trying to find, it's what's called the width, in this case delta t, times the functional output. So like f of 0 plus f of 1 plus f of 2 plus f of 3. So what is your delta t? It's the width between the t values, which is always 1 in this case. And then your f of 0 is the y values. That's the 32 plus the 19.41 plus the 11.77 plus the 7.14.
Okay.
So you're basically going to add up these numbers and multiply by 1. I will do the same, and hopefully we have the same result when we're done here. So I get 70.32.
I got the same thing.
So the area for the red is the same thing. It's delta t, but this time it's f of 1 plus f of 2 plus f of 3 plus f of 4. Basically, the difference is you exclude the endpoint in one or the other.
Okay.
And the width between the time values, the delta t, like the width between, from 0 to 1, 1 to 2, 2 to 3, 3 to 4, it's 1. So this is 1 times 19.41 plus 11.77 plus 7.14 plus 4.33. So if you want to go ahead and add those up, let me know what you
Yes.
come up with. We'll do the same. If you're creative, you can kind of redo the previous calculation to some extent with this, but
I got 42.24.
so I got, make sure I put it right. I got 42.65.
Hold on.
So it sounds like it's just a calculator error, meaning one of us is just off.
Oh, I forgot to put 19.41. That's why.
Okay.
My fault.
So which is larger? That's kind of what you're looking at, which is smaller.
Which one is smaller?
Which one
The
is larger? Yeah.
B.
Yeah. So the upper estimate is 70.32. The lower estimate is 42.65. Now, if you look at the numbers in the Y values here, like you can think of this as X and Y. The Y values are bigger for the first four, like they're getting smaller each time. So the upper estimate's going to use the first four values. The lower would use the last four because the numbers like
Mhm.
32 is bigger than 4.33.
Okay.
And that is relevant for part C. And there's not really a shortcut to this, like so just that this is the only way to do it. And for part C, you'll notice what they do is they say, imagine you're only going at 3, t equals 3. Let me snip in the table again and snip in the table here. So you don't care about that last one for sure. So it's like, are you going to use the first 3 or the last 3? And since you want the upper, well, you want to use the larger values. So you're going to use 0, 1, and 2 for that, the first 3.
Okay.
So if it doesn't make sense, I mean, I get it, but we have to do a lot more practice here to get this. You're going to use the first 3 values. So that's 1 times 32 plus 19.41 plus 11.77. So I want to add those up again. And I got here 63.18.
Yep. That's what I got too.
All right, that's your answer for this one.
Okay.
All right, so back to 2. Using rectangles whose height is given by the value of the function at the midpoint of the rectangle's base, estimate the area under the curve for the following function using 2 and then 4 rectangles. Okay. The first thing you're supposed to do is do this what's called delta x, which is b minus a over n. This is a, this is b, n is the number of rectangles.
Okay.
So for 2 rectangles, it's 2. So in your problem here, it's 6 minus a minus 6 over 2. So what does that become? 12 over 2,
Yes.
6.
Okay.
So what I tell students to do is to start with the leftmost endpoint and add the 6. So that gets you to 0, and then add the 6 again. Like that. And
Okay,
so like in that first problem we did, we looked at kind of the endpoints, but for the midpoint rule, you have to use the midpoint here, -3 and +3. I know maybe this isn't clear. This is just the mechanic of how to do it. The
it's making
midpoint.
sense so
Oh,
far,
good.
yeah.
Oh, good. Okay. So one of the issues with the virtual format is like I can't read body language.
Yeah.
And I can usually tell if students like have no idea or don't when it's in person, but it's not practical. And so anyway, so like what we're saying here is this curve, it kind of looks a lot like the one we looked at in question 1. So like normally we would look at kind of the endpoints there, but instead we're going right here and we're creating a mid rectangle like that,
Okay,
and then a mid rectangle like this. And so the height of the rectangle is f of -3 and f of 3, which is the same in both cases. And the width of the rectangle is 6.
okay.
So to find the height of the rectangle, we have to evaluate the function at -3 and 3, but they are identical. So, your pick. Why don't you put in 3 and tell me what this becomes?
Wouldn't that be 27?
Yes. So we got a height of 27 and a height of 27. So for two rectangles, it's 6 times 27 plus 6 times 27. So whatever that results in, which is 324 according to my
Yeah.
calculations.
Yes.
Okay. Now, unfortunately for 4 rectangles, we have to do the same thing. We have to actually restart from the beginning with this whole delta x thing. So for 4 rectangles, let me snip in that part of the question. And I'm sorry this is going so slow, but there's
No,
just
it's
no
okay.
shortcut here to
Mhm.
this. So now n equals 4. So your delta x is b minus a over n. Still the same b and a. It's still the 6 minus a minus 6 over 4. But this time 12 over 4 is 3. So you start at -6 and you go up 3. That's -3. Up 3 again is 0. Up 3 again is 3. Up 3 again is 6. So now you need 4 midpoints. So you need minus 4.5, minus 1.5, 1.5, and 4.5.
Okay.
So again, it's kind of, if we're going to make this really rough sketch, but the idea is that there's like at minus 1.5, there's a rectangle, minus 4.5, there's a rectangle. And then similarly, there's, another rectangle. These are not to scale, but something like that. They all have a width of 3 though.
Okay.
And so you got to find f of minus 4.5 or f of 4.5, whichever is the same, f of minus 1.5, f of 1.5, like that.
Okay. I got f of 1.5 is 81. And
No, cannot be. No, no way.
oh,
Because
okay.
it's 36 minus x squared,
Mm-hmm.
which means it's got to be smaller than 36.
Oh, I multiplied it. Oh my gosh.
Okay,
I'm so sorry.
it's okay. I'm here to make sure that things actually work out the way they're supposed to.
I got 33.75. Is that better?
Okay. Yep.
And then
So 33.75, that's the height of this one over here.
The
and this one over.
the 1.5.
Oh, yes, sorry. Yes, I'm way off. There we go.
And
So
then
33.75.
and then 4.5 is 15.75.
So now you're just multiplying. You got 3 times 15.75. And then you double that for the other one.
For the 15.75 doubled, it'd be 94.5. And
Okay.
then hold on. For 33.75, I got 202.5.
Okay. And then did you add them together?
Doing that right now. 297.
What I got as well. So none of this is difficult. Like none of the individual steps are difficult, but doing all of it together, I mean, that's a lot to ask.
Yes.
But that is, you will get a question. Like don't shy away from this. You will
Yeah.
get something like on there. All right, so let's move on to 4. So this one's similar to the one we just did, but I have one question about this average value, but it says here use a finite sum to estimate the average value of f on a given interval by partitioning the interval into 4 subintervals. So that's n equals 4. And a is 1, b is 9. So your delta x is b minus a over n, 9 minus 1 over 4, which is 2. So I always suggest starting at that leftmost endpoint, and then you add the delta x to it. So that's 3, and then that's 5, and then that's 7, and that's 9. You stop when you get to the rightmost endpoint, B basically. Now, because you want the midpoint, you're going to use 2, 4, 6, and 8.
Okay.
So your rectangles, and sometimes at some point you do stop drawing them, but your rectangle has a width of delta x. It's always delta x. And then I'm just drawing them arbitrarily in height, but then your height is f of 2, f of 4, f of 6, and f of 8. So in your problem, it's 3 over x. So your height is 3/2, 3/4, 3/6, and 3/8. Okay, so normally you would just find the areas of these and add them up. So why don't you get the area and add them all up? I need to look up the question to make sure it's actually what I
Okay.
think it is, which is I think there's another little step here that I'm not sure about. Get a total for all that.
I multiplied it by 4. I was thinking, hold on. I got 6.25.
I got the same. Good. So normally that would be the answer, but there's the thing in this question, and that's what I was trying to check in here. It says the average value. So we did this last time. The average value means you 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 um you um divide this by this 1 over b minus a. I don't know if you remember us doing that with the integral stuff.
Mm-hmm.
So you're that then you can see that that comes here. So it's 1 over 8. B minus a 9 minus 1. What it's doing is it's kind of leveling the height of the rectangles, so you kind of know the average height of all of them. Is it useful? I don't know. I mean, but that is the that is the answer. Now, as a fraction here, it's 25 over 32 is your final answer.
Okay.
I know there's a lot there. Any follow-up to that or any?
I think so far I'm understanding. I'm getting it. Yes.
Okay. All right. Okay. So next problem here, number 5. We're moving into new stuff here. This is different than what we've been doing. Okay. So it says write out the sum. So what that means, and we're gonna get to this, but this Greek letter sigma means to add. You're starting at k equals 4 and you go until 8, and you put it in this thing each time. So it's almost like you're writing. You say, okay, let k equals 4. Then it's cosine instead of k pi, it's 4 pi. Okay, and then what you're supposed to remember here is where is 4 pi on the unit circle? Well, if you go all the way around once, that's 2 pi, and if you go all the way around again, it's 4 pi. So you're back here, and cosine is the x value. The x value there is 0. Sorry, 1. Oh boy, that was bad. All right, so you can also just go to your calculator, make sure you're in radians, because your calculator doesn't know what you want to be in. You can't presume that it knows. All right, and then you say, okay, well, let k equal 5. So that's cosine of 5 pi. All right. So where's 5 pi? Well, if you go all the way around, that's 2 pi, all the way around again, that's 4 pi. Another pi gets you over here to this position on the left where the x value is -1.
Okay.
Then you let k equal 6. So it's cosine of 6 pi. And what you'll start to notice here is when you move by pi, you're going 180 degrees. So it's pi and then pi and then pi and then pi and then pi. You're always going back to these 2 points. So this one is 1. This is from your trig class, which
Mm-hmm.
you can always use a calculator. -1, and then let k equal 8, and cosine 8 pi is 1. Okay, now write out the sum. What I don't know is if it wants this column or if it wants this column. So let me check the wonderful internet and see if I can find that out for you,
Okay.
because I don't know what it wants. Sum without sigma notation, then evaluate. Check one more. It's good to get two sources whenever you're doing something. Okay, so what I think it wants here, and you're not going to like this, but I think it wants cosine 4 pi plus cosine 5 pi plus cosine 6 pi plus cosine 7 pi plus cosine 8 pi. And you can use copy and paste, but that is part A.
Okay.
For part B, you are going to actually do the calculations like we did and then add them up. So it's 1 plus -1, 1 plus -1, those cancel. So you end up just getting 1.
Okay.
I'm just looking ahead here to see if there's any more problems like this. It looks like they go the other direction now. All right. It looks like 8 and 9. Oh, they're there. There's 9. There's 8. Let's do 8 next. 8 is more like the ones we've just been doing. Now your calculator will do number 8. There's a way to just put this in exactly in your calculator. You know, great Google things out there to find that.
Okay.
I'm happy to show you as well, but it's you can find that. Now, in terms of like what you're actually doing here to find it, well, you're putting k equals 1 in, and then you're getting the result. So it's -16 times 1, which is -16. K equals 2, -16 times 2, which is -32, and so on. So at some point here, you will need a calculator because the numbers might get large, but we're going up by -16 each time. So the other thing you might do is like, you don't have to make this full list. You can just start writing. It's like -16 plus -32 plus -48 plus -64 plus -80 plus -96. And so we need 7 of these. 1, 2, 3, 4, 5, 6 plus -112.
Okay.
Right, so then you just add these all up. So go ahead and calculate that for us, please.
I got -448.
Perfect. All right. Any thoughts on that before we move on?
No.
All right. So we'll go back to 6. Because 6 is like going the other way. It's like um, can you figure out which one? Well, which ones? Because there could be more than one here. Like which of these gives you this sequence here? All right. And one way to do it is just to try them and see if they give you what you want. So like what I mean is like try the first one, put k equals 1 into here. So it's -3 to the 1 minus 1 power. Can you tell me what that becomes?
0 or
It
1.
becomes 1. So that works for the first one. Now let's try the next one. When k is 0, it's -1 to the 0, 3 to the 0. What does that become?
-1. It would just be 1.
Be 1. So that also works. That's not good. Let's try the next one here. How about -1 to the -2 plus 1, 3 to the -2 plus 2.
Negative, negative, -1. -1 to the -1. I feel like I should know what that
It's a
is.
little awkward. It ends up being 1 over -1.
Okay. And then that would be -1. And then 3, -2 plus 2 is 0. So it would be -1, right?
Yes.
Okay.
So that one's out. Okay. Now you got it. Okay, well, try k equals 2. -3 to the 2 minus 1 power. And, does that give you -3?
3, -3 to the -1 power.
Yes. Well, not -1. It's 2 minus 1.
Oh, yeah, it would be -3. Sorry, my brain is like off today.
So that worked. Now let's
Yeah.
try k equals 1. This one here. -1 to the 1, 3 to the 1. What did that become?
-3.
Sorry?
-3.
-3. Yeah, so that's also working. So we keep going here. -3 to the 3 minus 1 power.
It'd be
Is
9.
that 9? Okay. And then -1 squared, 3 squared.
9.
All right. Okay. So I'm convinced that it's A and B.
Okay.
If you're not, you would have to keep going.
Yeah.
Don't, there's like, from my experience, like you should go a few, but you don't need to go all the way. But that's up to you. That's like, you have to decide that.
Yeah.
So I mean, I think you check A and you check B and you're good.
Yep.
All right. So the next one here, it's the same idea, the exact same idea. You've got to try. One of them will work. One of them or 3 of them will not work. So you're looking for like the ones that don't work. Now, if you want kind of a shortcut here, it's probably to not start at the first number. Like if you were like trying to figure out how to like do this faster, you might go to the end. Like when it's 23, does it give you the last one there? But up to you, up to you. You can go to the middle one. You could say, all right, well, it's 20, what's the middle number? What do you think you would do on a test here? Would you just start from the beginning like we did in the last problem, or would you try to kind of,
I feel like
test taking strategy?
I would start from the beginning. These ones
Okay.
always confuse me because I always think I know what I'm doing, but then I get confused.
So this is -1 to the 19, 1 over 19 plus 1. So what does, so it is 1 over 20, but is -1 to the 19, is that a negative?
Yes.
It is. So it could be A, we don't,
Mm-hmm.
but, so your choice now is to keep going. Your choice now is say, okay, well, it worked for the first one. Let me try k equals 20, or you could go to B and figure out if B was wrong. Okay.
Mm-hmm.
I don't know what to tell you, as far as like a better approach, but
Yeah.
let's just try this. Okay. So this is 1 over 21. What is -1 to the power of 20?
It's
Positive or negative?
+1.
Positive. So that's looking good.
Yeah.
it's kind of like, well, do I try another one?
Mm-hmm.
I don't, you got to make that call here. I won't be there on the test, but it does work. So the answer is A,
Okay.
and you're good to go, so to speak.
We oh, never mind. Never mind. 9 is just really long. I don't know if you want to do that right now.
Yeah, we get started. It's up to you. You're the customer.
Um, good. We'll just do it. It's fine.
All right, so this stuff at the top here is super important. We need it for all the questions. So these are the properties of integration, and I'll try to provide the property each time. So the integral from A to A, so when the bounds are the same, this is always, always, always 0. So if the bounds are the same, it is 0.
Yes.
And the
Okay.
reason is because you're finding the area of an infinitesimally small. So this dx is infinitesimally small.
Mm-hmm.
So it has no area. Which I don't know if you agree with, but that's what the calculus says. So
Yeah.
All right, let's do so for these, what I have to do each time is I have to snip in the top parts. Let me do that, and then we'll grab part B. We need to be able to explain it each time. All right, part B. Part B right here. Okay, so part B, the integral from 7 to 2 g of x. So they give you 2 to 7 g of x. Okay, so the property here is that if you have the integral from A to B of some function, they almost always use d of x, f of x, d of x. This equals negative b to a f of x, d of x, dx. So in words, when you flip the bounds, you have to negate it.
Okay.
So in your problem, the original is -6. So when you flip the bounds, you negate that and it becomes 6.
Okay. Okay, I see.
These are not difficult, but you have to know the properties.
Yeah.
Like they're all like add, subtract, multiply by -1. There's no like calculus in this, even though you're in a calculus course. So now part C, take a look at that. So part C is 2 to 7 integral 9 times g of x. So you can always bring a constant out of the integral. You can always bring this out. So it's constant times integral f of x dx. So this 9 comes out, and they're telling you the integral from 2 to 7 g of x dx is -6. So this is 9 times -6, which is -54.
Okay. Yeah. Okay.
So again, like there's no like calculus. It's just
Mm-hmm. It's just properties. Yeah.
properties, add, subtract, multiply, divide. They're very intuitive. I feel like they're kind of like you didn't know you would still kind of have a shot at doing these correctly.
Yeah.
Okay, so this one is the integral from 4 to 7 f of x. So the letter does matter. So you know that from 2 to 4, f of x is 8, and f of x from 2 to 7 is 4. So the idea here is like if you have the integral from a to b, f of x dx, plus the integral b to c, f of x dx, this equals the integral from a to c, f of x dx. So the integral from 2 to 4, and we'll do this in your problem, 2 to 4, f
Mm-hmm.
of x dx, plus the integral 4 to 7, f of x dx equals the integral from 2 to 7 f of x dx. So notice that you have this number, this is 8, plus the thing you're trying to find, and you know that this is 4. Like you're trying to find this middle one.
Mhm.
And you know that the first one is 8, the last one is 4. So if you subtract 8 from both sides, you get -4.
Okay.
All right, so we can pick up there next time,
Yeah,
or
of course.
we can redo some of this, up to you.